Get which way to go and what is real. I wouldn't fall into my doubts anymore. Living on the last hope, darling, hold on. Living on the last breath, don't you lose the grip. We're living on the last hope, darling, hold on. We don't see it yet, but we know we need. We don't see it yet, but we know we need. We don't see it yet, but we know we need.
Hi, and welcome to Smiles Fun Live. This is part 2 of this series, Getting Started with Robotics. So do you want to build your own robot and don't know where to start, what you'll need or how to do it, then you're in the right place. So if you stick around as well, I'll show you some print failures that I had this week when I was printing some parts out for this very show. So let's get over to the... Okay, so I've got some questions for you. Do you own your own 3D printer? And if you do, what kind is it? And another question is, how many different types of filament do you own? So, you know, different colours, different types, and so I'm just interested to know what you guys have there. So without further ado then, so my name is Kevin. Come with me as we learn how to build robots, bring them to life with code, and have a whole load of fun along the way. So let's get over to Keynote, start our show off properly. So this week, as I said, we're looking at building, printing out the parts. We'll be downloading the STL files, finding the instructions. We'll be deciding how to, which files to print, because there's a couple of different types of robot that we can print. We'll be slicing the files with Cura. We'll be 3D printing, looking at 3D printer settings and how to use Octoprint, which is a really great add-on for a 3D printer if you're not already using that. And we'll also be, looking at preparation, how to level the bed, choosing the right filament colour and so on, and then printing the parts as well. So, downloading the STL files. Okay, let's get back to our keynote. So first of all, to download the correct files, there's a couple of different places we can do this for the SMARS robot. So the original place where SMARS was hosted was on Thingiverse. So if we switch over to Thingiverse, let's get Thingiverse open. And let's have a quick search for SMARS and see how easy it is to find. So we'll literally just type in SMARS, and the first one that comes up is SMARS, a modular robot. That's the one that we're after. So let's click on that and have a see what we have. So you can see there, that's Kevin Thomas's alter ego on Thingiverse, and you can see there November 22nd. I think we should mark that as a birthday. What do you think? 2017. And there's been quite a few different comments on that. A load of remixes. People have loved this robot because it's so flexible, so adaptable, very easy to build, not very complex shape wise or to be able to add things to it. So this is why it's so popular. So that's where you can download the files from. You can literally go here and just download all the files. So let's click that and see what happens. I've already given shown some love to Kev Thomas. So they're going to start downloading now. There we go. It doesn't take very long. They're very small files. And if we just open that up, and there we go. Let's have a quick look inside this folder here. So it's got a couple of different folders. The files are the ones that we're interested in. So these things called STL files are the ones that we're interested in. So we're going to have a look at them in a moment. So let's get back to Keynote. Another place you can go if that seems a bit complicated perhaps, you can go to smarsfan.com. So that's the website that I've created, that I maintain, and the idea of SMARSFan was to bring all the information together in one place about SMARS, because there's more than one place these bits of information are all stored, all the different parts and electronics and things. So here we can see on the screen now, this is SMARSFan. Let's just make that screen a little bit bigger so we can see what's going on. And what I've done there is just created a few different areas so we can learn what is SMARS, what does it stand for, Screwless Modular Accessible Robotic System. You can see a couple of pictures of it there. And we can see a statement from the original creator Kevin Thomas as well there. But if you want to get the files, that's very easy to do. We can just go to build instructions, we can click on the wheeled robot, and we can see there the list of all the different parts that we might need. So if you click on the chassis, for example, it'll take you to a page all about the chassis. You can actually download the file there, chassis SL.stl, and you can read a little bit about it as well. And you can see in context as well all the other things that relate to it, and some quick links and a video about how to create this as well if you wanted to create this in Fusion 360 or expand it. So great resource there that we put together. There's a couple of different ways that we can get information about the right files. So I don't care which you do. I think as long as you get hold of the STL files, that's the important thing. You might want to go to the source, go to Thingiverse and get them there. You might want to look at SMARSFan. Whichever you want, download the files, unzip them, and that's the first part done. So then the build instructions. Okay, so build instructions. So as you saw a couple of seconds ago on SmileSFan website, I put together some quite detailed build instructions step by step. So you can see there, we just go back to the home page again. We click on Learn, we click on Build Instructions, and then we click the Wheeled Robot button. There is instructions for the quad robot as well if you wanted to do that, but today, this series, we're going to be looking at the Wheeled Robot. So you can see there we've got some step-by-step instructions. There's a little navigation bar on the right hand side there, and there's some nice pictures on the left and some instructions about what we need to do. So we can click through them one thing at a time, and we can see all the information that we need to get started with that. So you can see the robot being built up there with all the different parts. So that's, I would say, the most authoritative place to get the information from. There are some files in the files folder when you downloaded them earlier. So if we go to, let's have a look on here. There's some PDF files, so there's an instructions PDF. We open up that. Let's have a look there. There's some instructions. It's a bit like an IKEA kind of, instruction manual about how to assemble this. Oops, let's get rid of that. You can see there, it's very simple to put together. One of the things that people get confused with as well is this step number 10 that you can see here. They ask, where'd you get that pin from? I didn't see an STL file for that little pin. And all that pin is, I'll just come back to the main screen. I've got some filament here from my 3D printer. And it's literally just taking that filament, snipping that off and putting that through the track. That's all that is. So it's not that you're missing a part. That's all that is. Okay, let's get back over to Keynote. So that's our instructions. Let me just bring up that on the screen there so I can see what I'm doing on screen. I'm managing lots of different screens here at the moment. Right. So build instructions is one place that you can go. You can also look at the PDF file that's part of the downloads. So deciding which to print. Are you going to go for the quad, which is a bit more of a complicated build? I've got one on my desk here. Or are you going to go for the standard wheeled one? So this video series is really about the wheeled SMARS, so that's why I've said hint it's this one. That's really what we need to go with. So let's choose that one, shall we, together? Now, slicing with Cura. Okay, so Cura is the software, certainly that I've chosen to use to slice the files. There is other software available. There's Slicer 3D, there is Simplify 3D, which I also purchased as well. That's commercial software. It's about £100, I think, to purchase for perpetual license. I believe they announced this week that they're working on version 5. The announcement seemed to be all about infrastructure though, so I'm not sure what new features it brings. Really, that's what people are interested in, not really the background stuff. So I believe it's like a mother and son who run the company as well. So it's very good software. It's very advanced structures, which we'll get onto shortly, about how it can help you support when you're building your model, the different internal structures that could be temporarily printed to stop the print sort of collapsing in on itself. But Cura is free. It's provided by Ultimaker, who are one of the largest 3D printer manufacturers, and they provide the software for free. So it's completely open source, very easy to get started with, but also very flexible. There's a whole load of features that you can get into and make some very interesting prints. So we'll talk about that as well a bit further on. Let me just make my notes, make sure I'm not missing anything out there. So what does a slicer actually do? And I'll load up the software in a second to show you how we use it. But what does it actually do? So when we get those STL files, what those STL files are is a 3D model of something. So if we take, let's take this little part here, for example. So I've got this little part here. This can be built in software like Fusion 360 as a model. And you describe all the different properties of it, and there's a file that contains that. And then when you want to print that file, you need to convert it to this STL format. And STLs are essentially triangles. There's lots of little triangles that make up a shape, and the slicer software can understand that, and then what it can do is it transforms it into instructions for your specific printer on how to build the model using a 3D printer. And the analogy I always think, if you was to sort of look with a magnifying glass at your 3D printer, as the sort of 3D printer head's coming along, it's like a tube of toothpaste. It's squirting out hot filament, which it melts inside the hot end, onto the board, and then it's just moving around very, very slightly, very small movements, which as soon as it's come out the hot end, it's already cooling down. So as soon as it touches the bed, it will start to solidify into the shape that it's being drawn in. So it's like a huge long tube of toothpaste, which is squirting out onto the bed. And the slicer software understands how to move the printer about. It understands things like how quickly to do this, so that the thing doesn't move too quickly, that it doesn't extrude properly. And extruding is what happens when the filament is pushed through the hot end onto the bed. And it understands things like, once it's done a layer, it can then move up and then do the next layer and then move up. And the layers can be very, very small. We're talking a tenth of a millimetre, something like that in height, very, very slight. And Cura lets us choose to what quality we want to print that. So what we will do is we will take those STL files that we downloaded, we will load them into Cura, and then we will slice it, we will apply that. So the slicing thing is automatic once you put the files in there, and all you then do is just tweak the settings that you're after. And what I've put on screen here is just as an idea how long it takes to print some of these parts. So I've got them next to me. I printed these out this week just to confirm, just so I've got another SMARS. So this is the chassis part. I've got a little video I can show you of that printing. And this is my own remix of it. So it's got some unique features like the little, there's like a little V design there on the side, which the standard one doesn't have. And it's also got in the base, I don't know if you can see that, there's like a little triangle, looks like a little play button that's just sort of in there. So that's printed. That takes about 8 hours to print. It's quite a time-consuming print, that one. It's the biggest print of the lot, but it's obviously what gives the robot its structure, its body. Sorry about just putting all the bits there. So what I've put on screen there is just 31 hours is how long it will take to print a SMARS if you have it in the sort of super quality mode. And we'll have a look at the quality modes in a minute, and we'll play around with that to see how quickly we can get it printed out if we want to quickly rush one out there. But the minimum time, I would say, is probably about 30, well, so the maximum time is about 30 hours, 31 hours. So the chassis is 8 hours, the slave and the master wheel, so I'm not sure if you're familiar with SMARS, but there's two types of wheel on the standard SMARS. Let's get this at the camera. There is this big lug thing that's sticking out the side is the slave wheel. So the slave wheel has a much larger, you can see that hole in it, and that will connect onto there. I'm not going to do it just yet. Whereas the master wheel has a very small hole in it, and that's because that the motor pushes into that and drives that wheel. So on each side, sort of diagonally, there is a slave wheel and a master wheel and a slave wheel. So to print a pair is 5 hours, so it's 10 hours in total to print the wheels. Then we need the motor holder, and the motor holders are these little things, and these will sit inside like so, and they hold the battery into place sort of like that. They sort of grab hold of the battery, and the battery sits next to them there. So they push down the motors as well and keep the motors in place. They snap into place. Then there is also these two components, so that's the sort of front, the face, and this little piece goes inside there, pushes into place and holds the rangefinder sensor in place, and then this slots into the chassis on the front, so it slots into little places there. So the rangefinder holder, the rangefinder cover, and the motor holders, they're 5 hours. I printed them all as one part, and we can have a look about how to do that in Cura as well in a moment. And then the tracks. So if you have mechanical tracks, I think I've just moved my other Smars to the other side of the room, but you can either have them on here. I've got some black tracks. You can either have them wrapped around a single wheel, or when you've got both wheels attached, these can actually be a caterpillar track that goes right round and gives the robot, you know, some real performance when it's on the ground. It can really sort of move forward on almost any terrain because the tracks allow, you know, really good grip. That's what I'm trying to say. Really good purchase on the surface. So pretty good over any surface. The only thing really to watch for is the speed of the motor. We don't want the motor to be too fast. So I would recommend you print about 4 different tracks at a time on the build plate. The reason I wouldn't do all 32 at the same time is because they're very small and they tend to warp on the bed if you're not careful, because it has to print one, go to the next one, print one, go to the next one, print one, you know, the first layer. And by the time it's got around to the first one again, that may have lifted a bit. So to sort of prevent that from happening, I would say build in the middle of the plate and just build about 4 at a time. Individually, they're about 15 minutes to print each, so I do 4, and that's about an hour's worth of a print, there or thereabouts, and you know, it's just about 8 hours worth doing batches of them like that. So that's the overview of slicing. So let's actually load up Cura and see what we can do with it. So I've got Cura loaded here. And you can see at the top here, there's 3 different buttons. There's prepare, preview, and monitor. Now, I don't use the monitor myself. That's for connecting to your 3D printer and monitoring the progress, where it's up to. I use Octoprint for that, and we will come to that momentarily. So preparing, let me just get rid of this part that's on the bed. Let's open up some of them STL files that we downloaded earlier. So you can see here, these are the files that we downloaded. So there's an ultrasonic. If you press space on a Mac, you can actually get a bit of a preview of what that file looks like. So that's the where's it gone? That's this part here, which is the ultrasonic holder. So let's say we want to print that part. So I'm going to open up that one. That's going to load it onto the bed. So this thing I can see in front of me here, I can move it around, is a sort of virtual 3D printer. So you can see there, that's what it looks like. And right in the middle of the bed is our part. And we can see on the left-hand side there, it says object list. So you can see on the right-hand side, it's given us an estimate. Based on the current settings, this will take 58 minutes to print. It'll use 4 grams worth of filament, and we're on super quality. So the layers are 0.12 millimeters in height. That's pretty dialed in. That's pretty extreme. So if we go to the quality there, and we change that to low quality, let's just keep our changes there. Let's see what happens now. On the lowest quality, it can do it in 26 minutes. So it's, you know, half the time, but the quality will be significantly different. So if we go to the preview button here and have a quick look, I just try and get a good view on this. It's not the best to be able to sort of navigate. You can see there, these lines, these are the actual paths of the filament as it will be laid down. So it will do this outline. It calls that a skirt, and we'll come to support and build adhesion in a moment. So you can see that, and if we move this here, this is the sort of layers themselves. So if we go down to the very first layer, this is what the 3D printer will do. If I just get rid of that for a second, and I try and zoom out, let's see if I can get it to do this. So there we go. What we can do is we can pretend to be the printer, and you can see the head there moving around. If I move this like this, it might be a better view of the screen. So let's see if I can get this to be displayed a bit better. So this playhead here, this thing is the 3D printer's nozzle, and we can see it's going to draw this path out around. It'll do it 3 times, and then it'll start to go to the middle, start to draw out a bit at a time, and that it'll do that for each of the layers. So we can see here, if we build up the layers, there is 37 layers in total. If we change that quality though to be super quality instead, let's just keep that change there again. It's now doing its slicing. and we can look now to see how many layers there are now. So 37 before, there's now almost treble the number of layers, 87 layers now. So they're much more refined, and that means that the quality of the print will be so much better. The curves will be rounder, the walls will seem smoother. All round it'll just be a better quality print, but it does take a lot longer to do that. So that is how we load objects in there. So if we were to load another object, so if we come over to back to the prepare, click on that little folder again to drag in some extra ones. So say we want to do it at the same time as that, the Malta holders. Let's try, yeah, the holding board 9 volt. They come as a pair there. So it's just stuck it there. I'm not too happy with that. You can click on the actual part and sort of move it about a bit. So we can do that. We can move them across as well. Let's just do that. Grab that green thing. I like them to be in as close to the middle of the bed as possible. But I don't want them to be too close together, just so that they're not touching. There we go. So it's going to redo its calculation to see how long it will take to print. And it thinks now it's 1 hour and 57 minutes. So you can see our print time is increasing. Now I don't know where you have your 3D printer, if you do actually have a 3D printer, but I have mine in my living room, so I have to try and keep my prints down to a sort of minimum time as possible, really, rather than have really long prints. So the chassis, that was an 8-hour one. I had to get up early start that one off, so that in the evening it wasn't still carrying on printing, because it makes a bit of a sound. I have ordered some quieter fans, and they're coming in the post this week, but we'll switch on the printer in a minute. It's just next to me, and we can see if you can hear it actually on the microphone. Anyway, so that's on the prepare. Now what's interesting on this one, if we zoom into these little pieces here, oops, they have an overhang. Just trying to get it into view. I'm not sure how to make it rise up. If I do, there we go, that might be a better view. There we go. So if you look there, these parts overhang slightly. So when I go to preview, if I've selected support structures, then it will actually put something underneath that to stop it from falling in on itself if it's within a certain tolerance. Now they have been designed to be 45 degrees or less, the curvature. So as the printer's building up, it can actually step out a little bit, a bit like dominoes. It can sort of just overlap them ever so slightly. And as long as that angle is 45, 50 degrees, something like that, it's fine, it won't collapse in on itself. But if you try and print just into thin air, obviously the printer can't do that. The filament will just loop, it'll just sag down. So you need some kind of support structure underneath, and you need to print that from the bed. So there's a setting in here which is called support, and you can do lots of different types of support. So we actually didn't have that switched on. If I switch that on, let's see what happens now. See if that actually does put some support in there. It might decide that it is going to do that. And there are different options for support. So I like the tree option. Rather than just creating like this has done now, just like a straight up and down structure, you can create one which is almost like a tree. It has like a main trunk and little branches that come out. So one of the compromises with doing structures is you don't want them to adhere to the bed, to the structure itself. You don't want the structure to adhere to the print itself. So when I printed out this one, and we'll have a look in a moment at, my lighting's just changed. Let me just change that back. Yes, when you print out something like this chassis, and I've got a video of that later on that we can see, there are some things in there that required support structures. So, for example, that circle there, the angle in there requires a bit of structure, and also underneath on the bottom, in fact, there is still some support structure fastened on there, and that's one of the things we have to watch out for, and why I prefer the tree one, because the tree can have a much bigger trunk structure, but then little branches to hold up the bit, and when the thing comes across the very top, it's hardly touching it. It means you can remove it a lot easier, and that's what it comes down to. You don't want to waste a lot of time printing out support structures, but you do need them occasionally. So Cura will help you with that. All we need to do is just switch them on by ticking that box there to say build support structures, and we can say what type of support structure we want. So I prefer the tree ones, which I think is an option in there somewhere. Yeah, you can say tree or normal. So if we do that, we have a look on here again. we might see that it looks a bit different than just them straight up structures that it had before. Just taking its time to do that one. That's obviously a bit more complicated of a task. Yep, there we go. So you can see they're more of an angle now. They start out with a main sort of trunk, and there's lots of little pieces that come out there. So that's support structures. Let's have a quick look else we've got in here as well. So infill. So when we create our 3D model in something like Fusion, really all we're defining is the outside walls, the surfaces that are the outside structure. So even something like this, it has walls. It has like a face there and a face there, and what's in between those two things isn't necessarily solid. Now you might assume that these things are solid inside, but that would make them. It would take a long time to print because every single layer would have to be a full, infill, as they call it. It would have to have a full infill of material. So, and it would also be heavier. So what we can do is we can create an infill pattern, and there are lots of different patterns to choose from. So we can have a simple grid, we can have lines, triangles, hexagons, cubes, all kinds of complicated gyroids and things. And they're quite interesting when you watch it print. So if we go back to here, and we dial this down a little bit, we might actually be able to see some of the internal. Just about there we can see this has got a little sort of funny pattern to it, and that's because it's got an infill, so that the middle of this structure isn't solid. The rest of it is because it's so small, it's too small to actually have an infill, so it's just solid, it's just walls. So the outside edges are considered to be walls, and they get a special treatment. You want your walls to be quite structurally sound, so they get a couple of layers there. What else have we got there? So that's infill. Then the material itself is the filament that you're printing. So filament, different types of filament have different properties. So if you're using PLA, what's that, polylactic acid, I think it's called. PLA is made from fructose. It's mainly made from cornstarch, from sort of a bit sugar based really. So if you threw that into the sea, PLA wouldn't be around in thousands of years time. In probably less than 5 years it would have just turned into food for the fishes, so it's quite biodegradable. That also means that if you leave something that's made of PLA outside in the weather, it does rust, it does sort of bubble and degrade over time and become brittle. But it is great for robotics. We don't need it to be, this is reasonably tough. This, if I drop this on the floor, it won't shatter. And that can be what temperature you print it at, on the build quality in structure. The infills and just the general structure of the thing. All those things can contribute to the rigidity of the PLA. So it's quite a rigid structure. You can also get things like TPU. I don't know what that stands for off the top of my head, but that's a rubber types plastic, and you find that on things like phone cases. It's that almost feels like silicon. It's quite bendy, stretchy, and we can use that for things like tires. We can use that for anything where we need it to be able to bend and retain a shape. So TPU is great fun to play with. But on my 3D printer, which we'll look at in a moment, my 3D printer has a Bowden tube. It has where the filament goes in, there's a little motor that sort of pushes the filament out. There's a little wheel that pushes it. And then it goes into a tube, and the tube goes all the way down into the hot end where it melts it and then squirts it onto the bed. So that Bowden tube is a bit of a problem when it comes to TPU, because you need to be able to sort of force it through, and TPU is bendy and flexible by its nature, so it doesn't do very well on printers with Bowden tubes. So if you've got something that's what they call a direct drive, where the motor is actually on the extruder motor is actually sat on the hot end itself, they're best for TPU. So I've not done any TPU. I do have some. I've got some, in fact, just under my desk here. So I've got some TPU here. It's a very small reel bit. I've not opened it yet. So I will have a play with that at some point, because I intend to use some tyres to give it some extra grip. What else is this? So that's the different properties. What's the melting point? So 200 degrees for PLAs, around about right, you can probably go 10 degrees less or higher than, depending what you want. And if you find when you're printing you get very stringy prints, or prints that not adhering, the layers are not adhering together, that's probably to do with the temperature that it's being printed at. And then we have other things like the speed, the travel. I don't tend to deal with them too much, but the build plate adhesion I do look at. So a skirt is like we have here. It's a single, it's almost like it's wiping the external area of where this print is going to be, just to create what does it describe it as there? Let's have a look what it says for skirt. The idea is that it doesn't connect to the actual model itself, but it gives you an outline of where the model is going to be, and you could probably stop it if it wasn't adhering to the bed at that point, so you've not actually wasted any, you've not got into your model proper at that point. You can have a brim. If we do a brim, and just watch that update in the background, that actually does connect to the edge. It's like a brim of a hat, so it's the sort of this bit that sticks out, and the idea of if you have something that's very hasn't got much surface area to stick to the build plate on, so if it was like a very tall tube, it might wobble when you're printing it, so you want to have something that adheres to the bed more, and a brim will actually help you do that. So you can see on the screen there, this wide flat area helps you adhere to the bed. We can have a raft. A raft is, as it suggests, it prints out something and then does the model on top. So if you've got an imperfect print surface and you want to just sort of paper over that, you can do that with a raft. So I find they can be a bit funny. They can give a worse surface to the bottom of the print. So when I print on my bed, I'll just show you on this one here, it's pretty flat. There's no real imperfections on the, can't really see that, can you? But it's it's quite a good surface. Very, very smooth, and that's because I'm printing on a surface that's been designed to be 3D printed on. So I'm just going to set that back to skirt. And what else do we have there? There's lots of other options as well, experimental ones. So one of the ones I found that was quite interesting is it can actually iron the top. So instead of extruding anything out, the hot end just heats up still, and wherever the very top surface is, it can go along and just touch it. And it's like ironing clothes. It gets rid of all the wrinkles, all the sort of imperfections, and you end up with a sort of mirror surface on the top. It does add a bit of time to the print, but that's one of the experimental options. So I think that's everything covered off there from a settings point of view. So my settings tend to be 200 or 210 degrees depending on the PLA itself, and also between 50 degrees and 70 degrees for the heated bed. So the bed itself, if you want the print to stick to it quite well, if you heat that printed bed up, it will actually adhere to it. Now you don't leave it too hot because it will actually start to melt away, and you'll see these sort of like melting effect on the very edges. But and you can also make it so that further up it lowers the temperature. So they sometimes have in the sort of cooling sections, what height do you want these things to change at? And it's similar with the fan. So there's a fan that blows the hot end cool, because you want it to melt the second it comes out of the print head. You want it to cool down. So there's two fans, one to cool the part and one to cool the actual hot end itself, so it can maintain temperature. So each of them tend to have two heads on them, two fans on them. So that's it really. They're the two main settings I have, and I go with all the default options that Cura provides, and it can come out with some very good prints. It can also come out with some very bad prints if you don't calibrate your printer properly, so we shall have a look at that shortly. Did I see somebody to give me a thumbs up a second ago as well? Give me a comment in the live chat as well, just so I know who's on. We'll have a bit of a chat in a moment. So let's get back to Keynote. So that was slicing with Cura. So yes, the thing that we didn't finish doing there is once we have finished our slicing, we need to save that file somewhere. So it will save it as a G-code file. G-code is the name of the instructions for the 3D printer. You can actually read these files, they're in English, but they're just a code, a number, and we can have a play with that in a minute when we switch the printer on. So if I save that onto the desktop and I call this live stream G-code test, Let's save that. So that's now saved to my desktop. We can open that up and we can have a look at that file in something like, let's open it up in TextEdit. Let's see if it'll let me do that. Let's just find TextEdit, there we go. There'll be a lot of instructions, don't get me wrong, but you can read it. So there we go. All these different codes tell the printer what to do, and there's some comments as well, like that little thing there. It just tells it that's a home, that's resetting the extruder, that it was generated with Cura, blah blah blah. So there we go. So let's get back to Keynote. So 3D printers and Octoprint. Not sure how long that other music went on for before I had my headphones turned down a bit, because I get a bit of an echo when I've got them switched on. Okay, so Octoprint. Let me move to my web browser and let me switch over to here. Let me see if we've actually got Octoprint. Yes, we've got it switched on. Now let's switch on the printer. So one of the things that you might be interested in, you might not, is I have a home automation system. So all these buttons on here are part of the Apple HomeKit interface, and I can switch on my 3D printer just by pressing the button there. And there's a little plug underneath my desk which will switch on the 3D printer. So I can just hear that kick into life. Now if I switch over to my split screen for a second, let's see if we can see that. You can see there I've got my 3D printer just sort of coming into life. So I'll just try and get a bit further back. Right. So you can just see there's a bit of a coloured display just down here, and you can see that red glowing thing is the sensor. For detecting where the bed is. It's the bed leveling BL Touch. So if I go into there, if I go into Octoprint and I just click connect, and I'll show you what Octoprint is in a second. If I just go to my screen share, you can see here this is Octoprint. It's just connecting to the printer. So if I tell you what Octoprint is, Octoprint, let's go to Octoprint, Google search, let's open it up. So Octoprint is software for a Raspberry Pi. It's kind of a pre-built Raspberry Pi SD card image, and you can connect that into your, load it up into your Raspberry Pi, and then you get this interface, this software that's called Octoprint. This is what it looks like. I've not actually got it plugged into my printer, so there we go, we need to just do that. There we go. Now try connect, it should be okay. And yeah, it gives you a web interface so that you can control your 3D printer. So I can see now it's just plugging in, it's just firing up, and we can just see now the printer. If I go back to the split screen, the printer is now moving around. There we go. So I can just see some messages coming through because of Facebook. Let me just kill that. There we go. Okay. So what it's doing now is it's just detecting the level of the bed, where the Z value is 0 on the 3D printer, and it uses that BL Touch device to do that. So if we want to level the bed, this is one of the important things we want to do. I just go back over to my screen there. This is a representation of my 3D print bed. Let us press mesh, update the mesh, and let's go back to our split screen and have a look what's going on there. So I'm getting some messages on the screen here that I don't think I should be seeing. There we go. So you can see what it's doing now. It's going to take 9 different points of the bed. I think it's Microsoft Teams that's causing that. How do we get rid rid of that. So yes, we can see that it's doing 9 different points on the bed. It's going to, you know, imagine like a noughts and crosses board. It's going to do one at each of the intersection points of that. Not sure why the messages are coming up on that side. It's because it's on my phone, that's why. There we go. So I can do that. So it's nearly done. It's about halfway through now. And once it's done that, we'll have a representation on screen in Octoprint of what the bed looks like from a height perspective. So it's measuring the height at 9 different spots on the bed. There we go. Okay, so that's finished. We can now home it. So we go back to Octoprint and we go to the troops. We go to the control at the top there, and then I just say I want to. I'm going to click on this home button here. So if I do that and then quickly jump back there, we can see it's now rehoming to the X and Y position. There we go. So it's just connecting to that little. There's a little switch on the very extremes of this, left and right. Okay, there we go. So that's our printer homed. If we want to now load in that file that we created a moment ago, so all I need to go is to my desktop. I need to just find that file on my desktop that we created. So go to desktop, Livestream G-code test, and I literally just drag this across onto Octoprint, and we can see at the very bottom of the screen there, it just says it's loading it, and then here on the top we have the Livestream G-code test loaded there. So I can load that up now. It's going to estimate how long it thinks it'll take to print that, and if I press print, it'll then start to prepare the job for printing. So the first thing it needs to do is set the temperature. So you can now see the temperature of the bed is going to be 50 degrees, so that's going to take a while for it to reach 50 degrees, and then the tool will be set to about 200. So we can just see just on the 3D printer there, it's just waiting to do something. So it's going to wait there until if I can actually show you what it says there. It says bed heating, so that's the little display on the end of there. So you can see all the wires I've got next to my printer there as well. So I'm just going to actually cancel that. I don't want it to actually print anything while we're here. I actually want to switch it off again because it's quite noisy. So I'm just going to pull the plug on that, and then I'm just going to switch it off on here as well. There we go. Okay, so let me just go back to screen share. There we go. I'll just put this back on the bed. There we go. Okay, so that's Octoprint. So it's software that you can download from octopi.org. You can download it for free. It's an image file for your Raspberry Pi, so you do need a Raspberry Pi. Raspberry Pi 2 upwards, I believe, is what they require for it. It doesn't work on Raspberry Pi 0. They're not quite powerful enough. So that's Octopi, and I use it because I can walk away. I can switch off my Mac. It's not connected to the Mac at all. This is all through the web. The Raspberry Pi is connected to the printer, and that's the thing that's monitoring where the print is up to and so on. So let's go over to Keynote and carry on there. So we talked about temperature, tree supports, quality settings. So choosing the colour. Okay, so what I've created here on the screen, if I just go back to my shared screen, is a little PDF file that you can download from SmarsFam, which is like a colouring sheet for you to do. So if you want to print your robot in different colours rather than it just being a solid colour, I would encourage you to do it in different colours as well, because the end result looks so much better. So for example, I've gone with a red chassis. I've gone with a yellow coloured face, the rangefinder cover. The rangefinder holder is white, and the wheels are white and the tracks are black. So you can just see there the track is black. You can actually see there's a little bit of red actually on the front of that from the build plate, because I didn't quite clean it off beforehand, but that's fine. I think it adds to the character of this particular one. So this sheet here is just for you to sort of tick, you know, which, not tick, but sort of colour what you think you want the different parts of it to be, and you can sort of colour it in. Maybe give it to your kids to do so they can choose what colour they think the robot should be. So just choose the tracks, the wheels, the rangefinder holder, and the chassis, and then the motor holders themselves. I'd also recommend PLA Plus, so you can buy PLA or PLA Plus. PLA Plus is a little bit more expensive, but the quality. So if you think the filament itself, I just get this one out here that I've got in my little desk drawer. If I was to look at this, the width of this with some calipers, it will vary along the length. So, you know, very small amounts, but these things do make a difference. If it's too varied, if it's like goes fat and thin along the length of the filament, that will mean you'll get blobs and things and imperfections. So you want it to be as perfectly true as possible. So the melting process going through the hot end doesn't get rid of all the imperfections. So if it's smaller than the nozzle, then you know it'll get bumps and things. So PLA Plus has less variance, but you pay more for that quality and that perfection. So if you want to get the SmilesFan colour sheet, you can either look at this link here, but I've also put a link on the play page. So if we go back to smilesfan.com, we go to the play page, and then if you see there, we've got the colour sheet. You can just click on that, and it will load up the PDF, and you can print that out yourself and colour it into your heart's content. I enjoy a bit of colouring in every now and again. Okay. So the recommendation as well is to level the bed before you print. You want to do this at least for each print session, I would say. You don't just want to print without looking to see if it's level, because you can have some problems, shall we say, with that. And let me show you what happened with me when I didn't level my bed and I'd not used my printer for a number of weeks and I'd had things resting on it. It was all kinds of bad shape. So we've looked at that from the, you know, printing the parts perspective. We have dragged the file from the desktop to the Octoprint, so the G-code is then loaded into Octoprint. We've checked that the bed is clean, it's preheated to the right, you know, temperature, both the bed and the hot end, and that it is level. And then, you know, all that remains then is to print. So let me show you what happened. So this is a print that I did went terribly wrong. It hadn't adhered to the bed properly. That was the issue. So I had to level the bed, try again, and I still hadn't quite got it dialed in. So you can see there it's better, but it's not perfect, but it's good enough. See that I've said a success loading because it's much better. It's a little bit of stringy there, but overall it's not bad. You can see some of the support structures as well on there, and just pops off the bed. This is the wheels, the white wheels. I speeded this bit up because obviously you don't want to watch for hours and hours for 31 hours. So here's not quite a time lapse, but a few selected points in time that I've videoed. You can just see the support structures being printed inside there as well. This is about midway through, near the end, and then they are finished. You can just see the support structure inside there. So as I pop them off and turn them over, you can see that its support structures are in the middle, and they just come out they'll be very loose. And that's the second set of wheels. So they'll be all next to, all together. And then this didn't go well. I've got them next to me here actually. I'll show you the difference. So they started to warp as they printed, and really it made them unusable as parts. So I'll show you them in a second. And these are the tracks. So I printed them 4 at a time, so I had to do 4 lots of 4, is that right? No, 8 lots of 4. video montage of the finished result. These are all the different parts you need for your Smars. See all the tracks lined up there, all the wheels, the chassis, the battery holder, the motors, the battery connector, the Arduino, the rangefinder and the motor shield. So there we go. So yeah, so here's some of the failed prints I promised I'd show you at the very beginning of the show. So you can see there, this has warped terribly. It sort of looks rounded, and that's where it's not stuck to the bed properly. It did seem to recover later on, but it's not really usable. And then these, that's not too bad, but then the one next to it, you can see has not adhered to the bed either. And these things, you know, are pressure fit. They're not going to work. And then I don't know where I put the rangefinder cover, but that was just terrible as well. That had all warped, so you couldn't actually push, you know, that piece into it to sort of hold it into place like that. So this yellow one is one I printed previously. So there we go. So I think that's all the bits I wanted to show you there. Let me just have a look at my notes. So I've got anybody watching on the live at the moment, or is it just people watching this on the replay on YouTube later on? So if you're watching live, I've got a couple of questions for you. I want to know, do you have your own 3D printer? And if so, what kind? And how many different types of filament do you own? Have you got a range of colours, or do you just tend to buy one block at a time? I quite like switching it out and printing things in different colours. So that's a couple of questions for you if you're watching live, and if you're watching on the playback, feel free to comment in the video down below and let me know what 3D printer you have, if you have one, or if you go to like a makerspace to print, and I mean, what kind of printer do they have? Very interested. There's more than just the type of 3D printer that I've got there, the Ender Pro. Uses filament, and you can get printers that don't have filament. They have resin, and the thing sort of rises out of like a liquid bed, and it uses lasers to harden. There's things like I'm not sure the name of it now, I should have done my research beforehand, but it's essentially a powder, and a laser beam will heat the powder up to make a solid shape, and a bit like a printer, it'll cover the thing in powder, cover the thing in powder, laser beam prints again, and then what you have then is a solid shape sort of arising from that. You can print in metal. There's a bridge that was printed in metal using a similar kind of technique. So yes, that's I want to know, you know, what kind of printer you have, what kind of filament do you own, do you have lots of different types, lots of different colours, what's the best kind of filament you've got. So I've literally just ordered some. I can do a bit of an unboxing here if you like. So this has just come for me, let me just do it like that. So I'm just going to open this up. This came today. I know what it is. It should be some black filament. So here we go. This is by is it Ryan? Irion? I have no idea how you pronounce that. But essentially it's just some black filament. And it's a diamond sparkly black filament. So this is PLA. It's got on there the quality of it. So it's 1.75 millimeter. Tolerance is 0.05. So excuse me, we're talking very small tolerances there. And the temperature is between 200 and 220. That's what's recommended. And weight-wise, it's a kilogram. So I like to buy these big, thick kilogram rolls to put on there. And you can see in the middle, it's got one of the silicon gel things. So what I said before about, you know, if you throw PLA into the sea, it'll degrade, or if you leave it outside, it rusts. If you leave it on your 3D printer for weeks and weeks and weeks and don't touch it, you can find it becomes quite brittle. So some people do recommend like putting it into like an oven or to dry it out, or I would find just putting it back in a bag with a silicone gel will take any moisture out of it as well. Just take a bit of a time for it to do that. So that's some sparkly filament, and the tracks that I printed out, I don't know if you can see these here. These are sparkly as well. They've got little bits in them that make it sort of shiny. So that's what I bought more of essentially. So that's the show for this week. So let's have a quick recap of what we've done then. We have looked at what it takes to print out a 3D printed robot. We've got all the different parts. I've got them here that we printed out this week. So we've got the wheels, we've got the motor holders, we've got the rangefinder covers. Oops, we've got 4 wheels, so there they all are. One on the floor as well. And it's about 31 hours to print that out. You could probably halve that time if you have the quality, but we want a nice robot at the end of the day, so why would we do that? And we've looked at what else have we looked at? We've looked at all the settings from Cura that we need. We've looked at how to print that using Octoprint, and we've looked at some failures as well. So let's go back over to Keynote and see if there's anything else we need to cover off. So for next week, we'll be looking at assembling this robot together. So it's more than just putting the parts together. There's some things require a bit of work. So, for example, this chassis may require some filing on this bottom edge here, because I don't know if you can see that on there. It's got some imperfections on the bottom edge there, so there might be some cleanup work required. Let's go back to my screen there on Keynote. So for week 3, we've got all about assembling the parts. So to do that, we need a battery, we need a 9-volt battery connector, we need some motors, the 150 RPM ones, the ones I would recommend. You can get them from smarsfan.com as well if you want to purchase them there. You can get the HCRS04 rangefinder, the range-finding ultrasonic sensor. You need some black and red wire, probably only about 20 centimeters of that. You can pick that up at any sort of hardware store. A soldering iron. I have a really inexpensive soldering iron. We'll have a look at some soldering, maybe some live soldering next week. And also some flux as well, some solder to solder it. So not very much there, but there are a couple of things we need, and obviously an Arduino and the motor shield as well, which I've not included on that picture. The motor shield was just off to the side of that picture. So yeah, that's everything we need for next week. So if you're coming along next week and you want to continue the build along, start printing the parts out now, and 30 hours later, thereabouts, you should have all the bits you need to get started with building your robot. So I don't think anybody joined me on the live stream today, so if you're watching this on the replay, like I said, let me know if you have a 3D printer yourself, what kind it is, and if you don't have one, let me know that you don't have one. I'll be just as interested to know that as well. And if you have some filament, let me know what kind you have and what colours you have. Very interested to know what kind of colours people have. I've got a bit of a rainbow of them. So yeah, next week we'll be assembling it, putting it all together, soldering, some soldering technique as well that I've learned along the way. Some common issues such as the tightness on the track. We'll see if the one I printed has the same issue and how we can get around that. And that's what you need for next week really, so just the parts. So thank you for watching. I hope this has been useful to you. I've really enjoyed putting this show together this week. I've put a few little clips out here and there on Instagram in preparation. Some of these transitions are put together in a single little movie, as well as some of the build failures that we did as well that we looked at earlier. So I hope you've enjoyed those too. So thanks for watching, and I shall see you next week. Just before we do that though, I nearly forgot something. That's dreadful of me to forget this. So what I forgot to mention is, first of all, to like and subscribe. Liking the channel, subscribing to the channel, ticking the little bell really helps the engagement on the show, and helps me get sort of pushed up the rankings, and more people get to see the video, and that means that more people can enjoy robotics, so helps everybody out. And also the comment of the week, I nearly missed that. I can't believe I nearly missed that. So yes, Sveinborn was the commenter of the week. So he said he was a bit late to the party last week, but he uses Windows because we were talking about what operating system to use. He started with DOS back in the day, which I did too, and he's only used an Arduino so far, but is looking at the ESP32 and other small chips. And his greatest problem has been printing. So he's done a bit of 3D printing design, but he doesn't have a printer yet. So he'll be hopefully using his local makerspace to help him. That's what reminded me of the I think I'd missed off there. So sorry for nearly cutting off from that one there. So thanks everybody for watching. I will actually see you this time next week, 7 o'clock Sundays, British summertime. It'll be very at the end of British summertime, so it'll just be GMT. So thanks for watching. I'll see you next time.